good day and welcome once again to our topic, sequence convergence. In this class today, I'll be solving one example on sequence convergence. We want to prove that the limit as n tends to infinity of c over n raised to power p is equal to 0, where c is not equal to 0 and p is greater than 0 are what? They are constants independent of n. Again, for us to prove that limit, it means we should show, it implies that we should show that the sequence c over n raised power p converges to 0. And for us to show convergence, it means we need to recall the definition of convergence. This says a sequence x raised power n converges to x elements of real number if for every epsilon greater than 0, there exists a k belonging to the set of natural numbers such that the absolute value of xn minus n, xn minus x is less than epsilon for all n greater than or equal to k. And as I have been saying from the previous videos, I said the first thing we need to do is to try to identify, you want to try to identify a k that works. You want to identify a k that works. In order to do that, you begin from there. Xn minus x is less than epsilon. And if that is less than epsilon, it means we have what? It implies c over n raised power p minus 0, and that gives us what? C over n raised power p. That's the absolute value. And this now, by the time we break that down, gives us the absolute value of c over the absolute value of n raised power p to be what? Less than epsilon. We have what? Absolute value of c over n raised power p. Remember that our p what? Is greater than 0, as we have seen in the question. So this is less than epsilon. Therefore, the absolute value of c is less than epsilon into n raised power p. That means our n raised power p is greater than what? The absolute value of c over epsilon. Therefore, our n is greater than what? The absolute value of c over epsilon all raised power 1 over p. And if that is the case, remember our n is greater than or equal to k. Therefore, our k also will be greater than what? The absolute value of c over epsilon all raised power 1 over p. Now to prove, we make certain assumptions. What are our assumptions? Let epsilon be greater than 0, and let k element of the set of natural numbers such that our k is greater than absolute value of c over epsilon all raised power 1 over p for all n greater than or equal to k. If that is assumed, you will then show it will show that what? This is less than epsilon. That is the absolute value of x minus n. It will show that the absolute value of the sequence Sn minus x is less than epsilon for all n greater than or equal to k. So we are going to begin from Sn minus x. Again, what's our Xn? That gives us what? C over n raised power p minus 0. And that is what? C over n raised power p. And by the time we break that down, we have the absolute value of c over the absolute value of n raised power p. And that gives us the absolute value of c over n raised power p. And since n belongs to the set of natural numbers, it means our n is greater than 0. And so we can take away the absolute value for n raised power p, and that's what we have done there. But our n is greater than or equal to k, where our k is greater than what? Our k is greater than the absolute value of c over epsilon all raised power 1 over p. It means that the absolute value of c over epsilon all raised power 1 over p will be less than k. But n is greater than or equals to k. So this will also be what? 1 over c over epsilon all raised by 1 over p will also be less than n. Therefore, the absolute value of c over n raised by p will be less than what? The absolute value of c over the absolute value of c over epsilon all raised by 1 over p all raised to power p. This removes that, and then it is less than absolute value of c divided by absolute value of c over epsilon, and that is less than epsilon. I am sure you know how we got that. Therefore, we have been able to prove that this, the absolute value of c over n raised power p minus 0 is less than epsilon. And that implies that the limit as n tends to infinity of c over n raised power p is equal to 0. In the next class, we'll be talking about sequence divergence. We'll try to give a definition for a divergent sequence, or what happens when a sequence diverges to positive infinity, and what happens when it diverges to negative infinity. And we'll take examples. However, if you have gained anything, or if you understand this video, you understand the concept of proving that a sequence converges to a certain real number, or showing that the limit of a certain sequence equals to x element of a certain real numbers, give us a thumbs up, like the video, and share with your colleagues. Thank you, and God bless you. I see you in the next video.